All right, so 7-4B today, let's see, there we go. 7-4B, I updated my notebook, so now I can tell you where everything goes. This goes on page 92. Page 92. Okay, so today we're still talking about translations, which is another word for what? What did we say? Shifting, yeah, so another word for shifting. But today we're not doing exponential growth, we're doing exponential decay. So how does that change the functions that we're writing? What does decay change about them? They definitely decrease, so your graph is going to be decreasing. The what? The range is still going to be all the y values greater than the horizontal asymptote. It's still above. Maybe. I'm thinking more about the decay. We know that exponential functions are decay if the b value is what? I know you missed it. I can't believe you missed it. The b value is less than what? 1. And we still want it to be positive, so it's got to be between 0 and 1. So that's one of the things that's going to be affected in our functions today. Now the way that the graph looks, like you said, the function's going to go down. It's going to decrease. So you're going to notice this general direction of down. Okay. But what you're also going to notice is that the b, the base, is like fractions. So here, the base is 1/2. What's the base here in this one? 1/3. And then the base in this one? 1/4. So do you notice how all of those bases are between 0 and 1, showing exponential decay? So everything is very similar to yesterday. You're going to start out with the same set of steps. So you're going to go find the what first? Horizontal asymptote. Am I recording? Yes, I'm recording. There is normally a bar. Let's see. Yeah, the recorder is recording. See? All right. So in our problems, first thing we find was that horizontal asymptote. Okay. Second thing that we were supposed to find was what? 1 point above. 1 point above. So if I go find 1 point above, is that the same or different from yesterday? The same, so same y-intercept, right? It's just the graph is decreasing instead of increasing, but it's the same y-intercept. Now, the third thing that we were supposed to find yesterday was the b value, right? And the way we found the b value was moving 1 to the right and then count the distance. We'll say count the y distance. You now have to move to the left, because if I move to the right, I can't really tell exactly where that is. But if I move to the left one, so if I move to the left one, here's that point. What's that distance? That distance is 2, which means that my b value cannot be 2, because my b value is supposed to show exponential decay, right? So it's supposed to be between 0 and 1. However, my b value is 1 over that distance. So that distance right here becomes the denominator. Do you see that? Yeah, squeaky. It's really the only difference. That's fine. So let's try the next one. First step is to find the horizontal asymptote. Next step is to find the point that is 1 above. And then the next step, because this is exponential decay, I don't want to go 1 to the right, I want to go 1 to the left. So if I go 1 to the left, here's that point right there. What's that distance? No, what's this distance? 3. So my b value is 1/3, 1 over 3. Same situation here, horizontal asymptote. My point 1 above. And my 0.1 to the left, it crosses right here. That distance is 4, so 1 over 4 is my b value. So do you notice how it's really, really similar to yesterday? It's just that b value is different. Okay? And we actually have the point -1, comma 1 over b as a point on our graph. So that's kind of where we're getting this from. My domain is still all real numbers. My range is still all the y values that are greater than 0 if it hasn't been shifted up or down, but the horizontal asymptote in general if it has been shifted up or down. So let's try some problems. Let's try some horizontal translations. So first step is to find the horizontal asymptote. What is the equation for it? Y equals 0. I love that you're not just telling me 0. It's an actual equation. This also happens to be the k value, but we're not shifting up or down, so that's why the k value is 0. What would be the next thing I find? The 1 point above. So 1 point above, that would be here. 3 is my value of what? H. Good. Because h is how much you move left or right, and if I'm moving to the right, that's a positive 3. And then finally, the b value, I don't want to go 1 to the right because I can't count up a large distance. I want to go 1 to the left. So that distance is what? The distance is 2, so the b value is 1 over 2. So when I create the function, I have f of x equals my base, which you might want to get into the habit of putting parentheses around it so that you know you're applying the exponent to both the numerator and the denominator. It's also not a terrible idea. Hang on just a second. Okay. So it's not a bad idea to keep your base in parentheses, even if the base is not like a fraction, even if it's like 2 or 3 or something like that. It's okay to put it in parentheses. So I'm going to put my base, 1/2, raised to my exponent of x, but it's x what? Minus 3. So my h value is 3, and I want to do the opposite. And I don't have anything that I'm adding or subtracting at the end because my k value is 0, so that's it. Is this okay? It's not 2. Remember, the b value is the decay factor because the exponential function is decreasing. So whenever we have to go backwards to count the height, whatever that distance is becomes the denominator of the b value. So it's 1 over that distance. So let's try part B, example 1b. So I'm going to find my horizontal asymptote of y equals 0. If I were writing my k value, if it weren't already there, I'd say that k equals 0. I'd go find the point 1 above, which happens to be at what? -5, 1. Yeah, so what is my h value? -5. And then because I have to go to the left to count my height, so left, here's that point. What is that distance? What is the distance? 3. So what is the b value? 1 over 3, because this is exponential decay. Is that okay? All right, so the function f of x equals the base, which is 1/3, to the power of x plus 5. There you go. Okay. Is there anything that you want to ask before we go on to the next one? All right. So I'm going to move on to the next screen, but I think that you guys are capable enough that you could tackle the vertical translations on your own, or at least in your groups. So I'm going to give you the opportunity to go through the 3 steps, fill in the information that's there, and then we're going to go through the problems, the answers together. Okay. So let's talk about example 2a. Raise your hand if you can give me the horizontal asymptote. Yes, ma'am. Oh, complete sentence. Thank you. Horizontal asymptote is y equals 4. I like that. Thank you. All right. I need another volunteer to give me maybe the k value. Raise your hand if you can give me the k value. Yes, ma'am. K equals 4. Technically a complete math sentence. All right, there we go. Can I get a new volunteer to tell me, I know the h value is 0, but tell me why the h value is 0. Like, how can I figure that out? Raise your hand if you can tell me how I know the h value is 0. Yes, ma'am. Because it didn't move left or right. You're absolutely correct. That 0.1 above is still on the y-axis, so it didn't move left or right. So we've got an h value of 0. Awesome. And then I need the b value from a new volunteer, maybe in a complete sentence. Yes, ma'am. The b value is 1/2. Very nice. So that distance is 2, and 1 over 2 is 1/2. So my function, correct me if I'm wrong, is f of x equals 1/2 to the power of x, and then plus 4 is my constant. Is that okay? Awesome. Okay, so how about some new volunteers now that you've seen it done? Need the horizontal asymptote from a new person, please. Raise your hand if you can give me that. Yes, sir. Y equals -3. Yes, sir. Okay, raise your hand if you can give me the k value here. Yes, ma'am. K is -3. I agree. So we've moved down 3 points. Good. I need the h value is still 0 because it's not moved from the y-axis. Now I need the b value, though. Volunteer for the b value? Yes, ma'am. The b value is 1/4. So here's that point right there. That distance is 4, so 1 over 4 is my b value. Yes, sir. Is the horizontal asymptote on letter A, is that a 4? Yes, this is a 4. This is a 4. Sorry. All right, so the function for part B, f of x equals a base of 1/4 to the power of x, and then -3 is my constant. This is good? Okay, so moving to the next one, we've got 4 examples to do. I'm going to do number 3. Just put it on my desk. I'm going to do number 3 as if I were doing it and making my key and not teaching you. I'm just going to talk through what it is in my head that I'm doing. You guys are going to work on 4 and 5 together in your groups. And then after we confirm 4 and 5's answers, then you will do number 6 completely alone. Okay? So number 3, if I were doing this by myself, I would look for the horizontal asymptote first. So the graph starts to flatten out right here. Yes, ma'am. Correct, because the point in the parent function is on the y-intercept. So if your point in the new function is also on the y-intercept, that means that your function has not shifted left or right at all. It stayed where it is. It might have moved up or down, but it stayed where it is with respect to horizontal shifting. Good question. So my horizontal asymptote, the graph starts to flatten out right here. So I draw my horizontal asymptote this way. That's going through y equals 1. That means my k value is 1. Excuse me, my graph has shifted up 1. It also means that my range is all the y values greater than 1. I go find the point 1 above the horizontal asymptote, which is right here. That's been shifted 3 points to the right, so my h value is 3. And then my b value is the distance that you count 1 to the left of that point. So this distance right here is a distance of 2. So my b value is 1/2. So if I were going to put all of these into my function, I would put f of x equals 1/2 to the power of x minus 3, and then plus 1. And I would say that my domain from the left to the right is arrow to arrow. So it's all real numbers. Is there anything you want to ask about the way I did number 3 in the order? So your job is 4 and 5 together with your groups. I'll get some volunteers to give me some answers in a moment. I'm going to pause the video and let you work. Okay, so I'm going to ask you for pieces. I'm going to call on people to give me those pieces, so make sure that you're ready. I'll give you kind of a preview. Please put that down. No scissors, no glue, no. All right, so number 4. I'm going to ask for it in the way that we should do it. So I'm going to ask for it in order from horizontal asymptote all the way to the function. Okay, so the first thing that I need is the horizontal asymptote, and along with it, I'd like for you to give me the k value and the range, since all 3 of those things are connected. So look and see what you got for the horizontal asymptote, k value, and range. I need that from Alex. Y equals 4. Okay, what about k? 4. And then what about the range? Y is what? Is greater than 4, because remember the range is from bottom to top. So if I have an asymptote right here and all of my graph is above it, then my y values are above greater than 4. Okay, next thing I need is the h value. So look and see what you put. I need the h value from Jasmine. What did you get for the h value? What kind of 2? Because if you move 2 to the left, what kind of 2 is that? It's a negative 2. Good. And then I also need the b value. So look and see what you put for the b value, keeping in mind that this graph is going down from left to right, and you have to go to the left to count the vertical distance. So can I get the b value from Chris? 1/3. Very nice. So this distance right here is 3, and I put that as my denominator. How about from everybody? What's the domain? All real numbers. Very nice. And then the function, if I put everything in its place, can I get a volunteer to give me the function? Yes, ma'am. Yes, ma'am. Fantastic. Okay. So number 5, perhaps you can just see what my mistakes are, because I'm going to fill it in. And so let me know once I'm finished if I've made some mistakes. Oh, wait. And I'll wait to write the function. All right. Help me out. What mistakes did I make? Because I know I made some. Yes, sir. It's a -4 for h. Why is it a -4 for h? Because it's going left. Good. What else did I mess up on? Yes, ma'am. The b is 1/2. Why is the b not 2? The graph is decaying. Good. No, sorry. So the b value should be between 0 and 1, because the graph, you're right, is showing decay. So it needs to be less than 1. Is there anything else that I messed up on? Yeah. What did I mess up on? The range. What should I fix about it? Erase the equal to part. So there shouldn't be an equal to part. It should just be y is greater than -5. Because can I have y values on the line y equals -5? No, what's there instead? An asymptote, so I don't have points there. Good. And then the function is f of x equals 1/2 to the power of x plus 4 minus 5. Is that okay? All right. So number 6, last one today. I want you to try it on your own. Please try not to ask each other for help. I'm going to give you about a minute to complete number 6. Last problem on our notes today, we're going to answer together on the count of 3 for each piece, so make sure that you're listening. Please don't answer before 3. Wait until I count to 3. So the first thing is the horizontal asymptote. I need that in On the count of 3. 1, 2, 3. Oh. It's going to get better. It's going to get better. Y equals -3. Okay, I need the k value on the count of 3. 1, 2, 3. -3. Awesome. I need the range on the count of 3. 1, 2, 3. Yeah, it's gotten much better. Okay. I need the h value on the count of 3. 1, 2, 3. English, please. You're throwing off the vibe if you throw in other languages here. I need the b value on the count of 3. 1, 2, 3. 1/4. Very nice. So if I go here and up, that distance is 4. So 1/4 is the b value. And then I need the domain on the count of 3. 1, 2, 3. All right. And the function, this is going to be real fun. Okay. F of x equals, give me the next piece. 1/4. Give me the exponent. X minus 2 minus 3. Yes. Okay.